Okay, this recording is to describe the process by which we're going to identify and record the locations of the pacing leads in the AUH patients. There are usually 2 electrodes on the right lead and 4 electrodes on the left lead. So we need to identify those, and we need to put them in the cardiac coordinates so that when we do the analysis and show a bullseye plot, we know where the leads are on that bullseye plot. And so here's an example of a case in which we've done the CT a few days after placement of the leads. And we can see here's the down on this position on the anterior wall is the left lead. So here's one lead there. There's one here and one here. These are the electrodes. It's all one lead. And so this is the most distal lead, which we call left lead 1. And then the second most distal here would be the left lead 2, etc. And so what we're going to do is we're going to go into Horos. We're going to identify each one of these items. We're going to save those positions into a binary file that Horos writes. Unfortunately, you can't just look at that file with an editor because it has all of this crazy binary info in it. However, there is ASCII text in there that identifies where the 3D coordinates of each lead begin. And so I've written a Python script to go in and find these positions and write them out into a normal Excel file. So, but the first thing we have to do is find the leads themselves in one of the patients. So let's start at the beginning. So here's Horos, the basically directory of studies that we have. And let's go out and we'll load into Horos the next AUH study. This one is 10041. So we'll go out and we'll look for 10042 and load it in. Should be in here. I go here. So these are the unzipped second acquisitions. So if I sort that, I see 10042. I'm going to open that. Remember, I did import, and now I'm identifying the folder to import files from. So I'm going to open that folder. I'm going to copy the links, and it will go out, find those files, copy links to those files so we can now look at them. The series that we want to use is this one, which I believe this is 1 millimeter slice thickness, this Flash 1.0. It should have close to 200 files in it. Oh, I'm sorry. It's this one we want to use, the 0.75 millimeters, because it has more slices. It's got 223. So it's Flash 0.75 is the key. And it usually will be the series that has the most images in it. So if I double click on that with my mouse, it'll bring that series up for viewing, and we can page through. We see our first LV leads. They look like they're pretty high in this patient up here. And then we go down to here. That could be the most distal lead there, which is still really high in the left ventricle. Oh, there's one more lead right here. Okay, so that's going to be the first one. Okay, and then here we have the right ventricular leads. So that wire goes down to the apex here. Okay, so we're going to mark those 2 locations as well. In order to get the orientation of the heart correct, such that we find these locations in cardiac coordinates, we're going to identify 3 points to help us get into the cardiac coordinates. And to do that, we'll take this volume of data and we'll go into 3D multiplanar reformatting, or 3D MPR. And that will bring up 3 panels where we're looking at the patient in the axial view. This is the coronal view. We're looking from the patient's chest towards their back. And this is the sagittal view. We're looking from the patient's left arm through towards their right arm. The first thing that you do, you're always going to do the same thing to get into cardiac coordinates. You take the axial view and you rotate by pulling down on the blue line to about 45 degrees. That's a good start. And you just center that up so that it's cutting through the heart as best as you can. This is an iterative process where we're going to jump between this view and this view to get the long axis of the heart just right. So we can now take this view over here and same way, except this time we're going to take the purple line and rotate up. And so that now makes the blue line, or this view, which is the blue axis. You see there's a little blue thing in the corner here. That gives us the short axis view of the heart about halfway down in this view. Okay, so we've done pretty well at centering it up here. What we can do is we can put where the cursors cross right down at the apex. So you can see that in this view, if I do two fingers, I can roll up and down the slices here. So I just drag my two fingers down. I'm right at the apex there. And so this, essentially the crosshairs are right at the apex of the heart, and that's good. While it's at the apex, I set the angle from that point to the base of the heart such that this yellow line bisects the top of the heart. So here's one side of the mitral valve over here. Here's another side of the mitral valve. I'm going to change that angle so that I'm going right between those two. So I'm going from the apex up through the top of the heart and bisect it. And I'll come over to this view. I'm still at the apex, and now I want to go halfway between this point, which is the top of the left ventricle, and this point, which is the top of the left ventricle. And so now I'm in a view in which the line that is going down the middle of the heart, again, I'm just going to page up through these, goes right down through the center the whole time. So if I go back and I use this, my two fingers, to roll up and down in this view to get the blue line to get to about the 50% mark between the apex and the base, halfway. It doesn't have to be exact, but you want it about halfway. And then you look at this view and you can see that the yellow line is intersecting the anterior wall and the posterior wall. This purple line is intersecting the septum and the free wall here. To get it into the cardiac view, I would rotate it just a little bit that way, such that there's a sort of symmetry between where the right ventricular free wall comes and hits the left ventricle here and here, such that I'm sort of parallel to that line. And that angular rotation will set up a point in this image. This is the yellow image, right? It's this point right here is the same as this point up here. And that's what I'm going to mark as the anterior position, right? So I'm going to mark three positions using these images. I'm going to mark the apex, the base, and the anterior position. So to mark those positions, I go into my ROI controls here, and I pull down point, right? And so now I've turned my ROI into a point. And so when I click, it's going to define a point in the image. First image or the first point I will define is the apex. And so the apex, I'm going to put it in the myocardium where the purple line intersects the myocardium right here, and call that the apex of the heart. In order to click it down there, I have to shut these lines off, because as you can see, if I do anything, I'm controlling the line. I can't put my point right over top of the line, unfortunately. So I need to take my mouse over here, shut those lines off by clicking off the axis, and come back here and put the point there. I'm going to do that while I'm going to go back, turn those lines on, watch where that line is in the apex, shut it off, and then that's my point right here. So I'll click that point. And that is the apex. The base of the heart is going to be halfway between this point and this point. So I'm just going to, it doesn't have to be super exact, but I'm going to say that's the base of the heart right there. Now, I don't want to put it above those 2 points. I'll just put it right where that is. And we can click on the purple line to get the halfway point. we want, which is right here, right? So you look at that, keep your eye on that, click it off, and you put your base here, okay? So that's halfway. And then halfway between these two, which is about here, but we can click the thing back on, it's the blue line basically. I'm going to put my anterior wall. This is the mark of the anterior wall. I'm going to click it above here, just outside the myocardium, just a little bit, and it'll make it easier to identify it when we go looking for it in another view. So here, I'm going to look at that blue line, turn it off, and then come in right in that same spot, click on a point that I'm going to call the anterior wall. And you can see it shows up right here. That is going to define the coordinate system of the heart. These 2 points define the long axis, right? The vector from the base to the apex. And then this point defines sort of the zero angle, or what is the anterior wall, and everything will be measured from that in terms of angular position. So now I can click this off, and these ROIs still stay in the memory of Horos. So I go back to the images, and then I can go up and down the axial image stack and look for the slice in which the basal point shows up. And I'm going to turn on again the point, right? And I'll select that point. It just highlights it. I didn't put a new point there. It just highlights that point. I'm going to rename that point, and I'm going to name it BASE, all caps, base. It's important that these words are the same every time, because I search for them later in the software. So now we're going to go down and find the apex, where that is. And I'm either using a roller on the mouse, or I'm using 2 fingers to drag down, and I go down through slices, or I can use the left arrow, right arrow. And that becomes helpful sometimes, the arrows, when you want to move just a single slice. So 1, 2 arrow hits, and now I've got this one. This is in the myocardium, so I know this is the apex. It's not that anterior wall marker. So I highlight it again. I've got my ROI selector on point. I go to ROI rename, and I type in, instead of base, we're going to type in apex. Okay, so now I've marked that one. Now we need to go find the anterior wall marker. So we'll go all the way down, come back all the way up. Just driving through the slices, And there it is, right there. And I know it's just outside the myocardium. That's where I put it. So that's the anterior wall. So we put ROI, rename, and we're going to call that ANT, capital ANT for anterior wall. Okay. So now I have 6 more to go. I have 4 on the left lead and 4 on the right lead. The easiest, quickest way to do this is to go back to a 3D mode, and not the 3D NPR, but the 3D volume rendering mode this time. Hit that button, and now I see the whole volume rendered heart. I go to my center and window, which is the last button on the top left here. Click that and press down the left key and push that up, and it will set the threshold that things become transparent. Okay, so now low Hounsfield units are not transparent. As I go up, you have to be a very high Hounsfield unit thing to be still seen. And so all the tissue's gone, and I can see right through to the leads. So let's go, we'll click on this little cube here, and that means I can push down the left button and rotate around to see where things are in 3D. So now I have a really good shot of where my left leads are, okay? So I can use the magnifying glass to zoom up, right? And now go back to the point selector for the ROI, and I'm going to select the most distal, that's LL1, left lead 1, left lead 2, left lead 3, and left lead 4. Okay. And let's go back to the little cube, and we can rotate that around, and there's our points are marked, and it's very efficient, really fast way to do it. Here I've got 2 electrodes on the right lead. So I'm gonna, with the same activation of the point ROI, I'll say that's my, oops, my bad. Here we go. Oh no, it broke. For some reason, it won't go back into ROI mode. Let's see. Can I get it to go back if I move it around a bit? This is frustrating if it's not gonna let me go back into ROI mode. No, that doesn't seem to have. All right, so let's get out of here. Bloop. So we have, using my left arrow again, I see the 4. Okay, so what I'm looking at down here is the ROI for the left lead, right? So if I push the arrow such that I go all the way off the end of the lead, see the lead stop there, come back, there's my position of my left lead. I think that I might just change that a little bit. So I can actually delete it and put it right here. And then I'm going to change the name to LL1. Okay, so it's my left lead 1 is done. Use the arrow key to come up a slice. And then here's left lead 2. I think it's left lead 2. So let's rename it as left lead 2, return. And then use the arrow key to keep coming up a slice. Okay, now we got an issue in that they're in the same slice, which is a kind of a pain in the neck. So what I'm going to do is I'm going to put one of them in here. So I'm going to delete this one. And I'll move a slice this way and put it on that slice. Okay. And I'm going to rename it. And that's going to be left lead 3. Okay. And then one arrow will get me back to this one, which is left lead 4. So select it with a left click. You're still on this ROI function here. And then we'll rename that ROI left lead 4. Okay. So that's 4, 3, 2, and 1. Okay, so the left leads are done. Now let's go. We had a problem with these right leads. Let's see, did it drop any on there? Well, it said it wasn't. Yeah, there's one there. 1, 2. Oh, I dropped 2 of them on there. Okay, so it was dropping them. It just didn't have the classic graphic. So we'll select it. And this is the one that's farthest distal or towards the end of the lead. We're going to rename that RL1 for right lead 1. Okay. And then let's make sure we don't have another one after that. No, nothing there. And then there's that one. So we will go click RI rename. And this one's going to be right lead 2. Okay, so that's everything. We've done 3 markers to get the orientation of the heart. And we've done 6 markers, which are the electrodes on the 2 leads, the right lead and the left lead. Now to save where those locations are into a file, we go back to this ROI pull down. And what we're going to say is select all ROIs in this series, just in case one got unselected. And so now that they're all selected, I can write them all into this file. And we're going to save all ROIs of this series. You could try save selected ROIs, but don't do that. The software works on this. It's save all ROIs in this series. So just do that. And we actually have it. Okay, lead positions. Okay. And we're going to call this, we look at the name is 142. Okay, 10042. So I can say 10042 is the This is a proprietary Osiris Horos file format, and we just save it into that format. Okay. You can, at this point, let's go to the folder and we'll open up a new directory and we'll look at AUH analysis, lead positions. Here's our 42. This is the file we just did. Let's, for grins, let's just open it with a text editor. Okay, and so when we do that, it looks like this. Okay, so it's got a whole bunch of gobbledygook because it's written in a binary format. It doesn't format as an ASCII, but inside that binary format, there are ASCII characters that are giving those 3D coordinates. And there are ASCII characters giving those labels that we put in, LL1, LL2, they show up in this file. So if you, in TextEdit, if you search, so if I do a Command F and I look for LL1, there it is, right? So when I read this file, I'm going to know it writes them in arbitrary order. It doesn't write them in the same order every time. So you have to know this. And then the next thing you look for is POS colon. And this position then tells you, okay, coming up, this 3D position tells you these are your numbers, right? And so I look for those as well. This has 2D position and 3D position, so I just use the 3D positions. But anyway, we get a program to do that so that we don't have to worry about it. Okay. So that program is in one of these Jupyter notebooks. It's read Horos saved ROI files. And the only thing we have to give this program is the name of that file that we just did. And so I'm going to change this to 42. I've done 41 before, so let's put it in there. Just so that I remember it's been done. So here's the list, and we'll change this program so it loops over a whole bunch of files after we get all the markers done. We don't have to do this every time. We just do this once at the end. And so it goes out and it finds that lead ROI file that we just saved, right? And it looks inside that lead ROI file for this 3D pause string, and then it knows to look downstream for the numbers, XYZ coordinates. It looks for these keywords that we typed in. So you got to type those in correctly. If these are wrong, it'll fail. And then we can just run this. So let's say Command Enter. It just changes all these numbers here. There's 2, 4, 6, 8. So that's a problem. We got 2, 4, 6, 8. 2, 4, 6, 8. Yeah, there should be 9, right? And so we'll see which one's missing. Apex is there, base is there, anterior wall is not there. It did not get saved for some reason. So we need to go back to, so see these orders change every time. I never know which order it's going to write those things. So let's go back to Horos and we'll see why is the anterior wall not selected. We had it. That's the apex. Okay. Come down here. Is it here, right? Oh, I don't know what happened there. Its name got changed to LL4. I didn't do that, did I? And this is, oh, because it showed up in the same slice as this one. Okay. So what we're gonna do, yeah, we're gonna delete this. Okay, remember where it is. We're gonna go one more slice down and put it there and call it anterior. Not RL ant. and anterior. Okay, so now I've got anterior. All right, the next LL3, LL4 got deleted. When I deleted it, deleted both of them. They're linked somehow. Huh. Okay, so I got to put this one back. Click on it and call it LL4. Wow, this was exciting. That's LL2, LL4, LL3. Okay, let's try it again. So now we go into ROI. We select all ROIs in this series. Okay, and we hope they all have individual names. And then we go and we save all ROIs in this series. And we're going to save it into the file we saved it before. And it'll say, do you want to replace that? Yes, I do want to replace it. So now, when we go back to our Jupyter notebook here, it should give us 9 of those. Anterior, base, apex, 2. Yeah, I got it. It's 2, 4, 6, 8, 9. Okay, so now we have 9 points. Everybody's good. Okay. And this program wrote out a Excel file or a CSV file, and it looks something like this. Unfortunately, lead CSV. And if we look at it with Excel, let's see what's in there. So, oh, this is what the file is supposed to look like here, but that's, shoot, forgot. I gotta delete this because it opened it and wrote stuff into it in addition. So we gotta delete that. So let's go back to our Jupyter notebook. Now the file's deleted. We'll run it again. We'll write a new file. Okay. And here's the new file. And we're gonna open with Excel. And this is what it looks like. So we have, I sort on these guys. So we have anterior, apex, and base. Those are the coordinates that were read in. And then LL1 through 4, these are the left lead 1, 2, 3, and 4. Left lead 1 is the one that's most distal, the farthest away. And then right lead 1 and 2. Okay, and so this is the fundamental data that we were after, right? And the coordinates, those coordinates are kind of arbitrary, right? They can move all over the place, but we're going to construct a cylindrical coordinate system using these 3 vectors here, anterior, base, apex, and base. But we're going to do that in MATLAB. And so we go over to MATLAB. And this is called make cylindrical from Horos points. So this makes the cylindrical coordinate systems from the Horos points. And we're going to first go to our new data here, which is, then we'll loop this thing too. We don't have to do it by hand for each one. So here we go. We hit return, read all that data in. It read in the data from that CSV file here. It's everybody's labeled. And then we come down here and we map the lead points into a cylindrical coordinate space. And you can see these leads are way up towards the base, right? So this is the apex. As we go up here, this is the base. And the last lead was actually, let's see, 1.24. So the last lead is way the heck out here. It's like, it's beyond this. It's just over here probably. So it doesn't even show up on this map. This is lead 1, lead 2, lead 3. And those are the right leads. But this is what we need in order to determine where the pacing is happening in this patient. So if the pacing is between lead 1 and lead 2, then this is the region of pacing right here. If it's between lead 1 and lead 3, then this whole thing, so, or it's between these 2 leads, etc. Okay, so we can save this. And I usually, I think I'm just putting them back in here. Yeah. Oh, it's already been saved. I put it in the, I automatically saved it. Okay, and so that's the processing for one patient. And at the end of that processing, we have those CSV files and we have the FIG file where we know what the orientation of the leads are in that location. Okay.